Yo, 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 yo. What? 1493. Longest subarray of ones after deleting one element. Given a binary array nums, you should delete one element from it. You should. Okay. Return the size of the longest non-empty subarray containing only ones in the resulting array. Return 0 if no such subarray exists. All right, so if you have 1, 1, 0, 1, you can delete this 0 and then you have 1, 1, 1. If you have 0, 1, 1, 1, 0, 1, 1, 0, 1, you can delete this 0, then you have 1, 1, 1, jump over that, 1, 1, 5 ones in a row, so the longest subarray is 5. 3, so 1, 2, 3, so 3, 2. Okay, so I guess the should is more of an imperative should, like you have to, absolutely have to delete one element. So, okay, that's weird. So you have to skip one element. So in this thing, maybe you skip the first one or you skip the second one, you skip the third one. It doesn't really matter. But yeah, so this problem feels very DP, dynamic programming S, right? Because you're gonna you kind of do like a prefix sum idea of trying to find the longest. Use a prefix sum to find, the longest subarray of all ones. So you just keep counting the number of ones you've seen so far, and that will give you the longest subarray of ones. But you want to use a dynamic programming approach of saying, well, what if I skip this value or I don't skip this value? What kind of information will that give me? So if we model this problem as a kind of like a graph, so let's look at this one because it's a little more, I guess, involved. So we have 0, 1, 3 ones, 1, 1. I swear that this is actually hurting my head, like it's putting a lot of pressure on my brain or something. It's weird, but Pokemon. 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1. Okay. And then we'll treat these as nodes. So for any node in the system, right, you can choose to continue the path, right? Or you can skip. Okay, so we can choose to continue the path, meaning that you just choose the previous node and try to find the longest path. Right, so this is basically saying like I can go from 1 to 1 to 1 to 0 to 1, right? Or I can skip a node. So if I skip a node, we'll do that in a different color. Right, so for any node, I can skip at least one. Right. Okay. So we want to find the longest path of ones in this system. For some reason, I forgot to do this one, which is weird. Did I forget to do a bunch of them because I was trying to be cute? Yeah. Okay, so 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Okay, now it's good. All right, so you could say, okay, well, this is the DAG system, right? Because from any node, you can skip one position or you can go to the next node. So we just need to find the longest path in the system with the highest sum, right? So that's close, but you'll notice that in this problem, you can do something that's not right. So you go 1, 1, 1. You skip this one, you go here, you go here. Now, if you ran some sort of dynamic programming approach here, the problem is you've already used your skip, right? Because you only get one skip. So this problem might be like, oh, I'll just go here, right? but you can't skip twice. You can only skip once. So this doesn't capture the fact that you can only skip a node once. This is capturing the fact that you can skip twice, or you can skip any infinite number of times, right? Because once you skip, you can skip again. Well, I can skip here and get to the next node, and skip here to get to the next node, skip here. But there's a difference, right? Because after I skip, I'm in a different system, right? After I execute a skip, I can no longer skip at all. So I guess the way to articulate that using this graph would be to instead build the system a little bit differently, right? Because there's a difference between being at a node when you haven't skipped yet versus being at a node when you have skipped. Does that make sense? Because once you skip, you can't skip again, so you don't get those additional arrows. So you can always go to the next node, right? But once you execute a skip, you can't skip again. So what we'll do to kind of notate that, right, to capture that fact in this graph, is create a copy of the graph. And then we'll say, well, when you skip a node, you can no longer skip a node again. So from any node, you can decide that you want to skip a node. And notice that once you skip a node, you cannot be skipped again, right? And I guess there's these things here going to nothing, but it's kind of useless because you're not going to get any added benefit from doing that, right? There's this skipping this node here. So now it becomes a question of finding the longest path in this graph. And you'll notice that you can traverse down this graph, but once you skip a node, right, because it's better to go down this path because there's another one, there's no more skipping, right? Since I made it like this, now there's this notion that once I skip, I no longer get that green skip node, right? So I've remodeled this graph in a way such that it meets the constraints of the system, right? I've remodeled this idea into a graph and captured the fact that, okay, once I skip, I can't skip again. So now it just becomes a question of finding the longest path in this graph, right? So for any node, here, like, longest path for any node here, right? It's the maximum of not skipping, right? So either I can go from here and choose a node before me where I've already used my skip, or I choose a node where I'm going to use the skip to get here, right? So for any node, this is the system. I either to get to this node, so I'm trying to, right now what I'm doing, I'm trying to develop this recurrence relationship, right? Either I skip, either I choose a node such that I've already used the skip, right? Because in order to get to any of these nodes before, I've had to use a skip to get there, right? So there's actually no way to get to this node. There's no way to get to 1 because there's no path from this system to get to 1, right? Because assuming that I'm down here assumes that I've already used the skip, right? Because the only way I get down to this system is from using a skip. So if I skip 0, I end up here, right? So that's the only way I can get to 1, but I can't use 0. I can never get to 0 because I can't skip. The first thing I can skip is 0, so I can never have it be the thing that is used after something is skipped, right? If that makes sense, right? Because I have to skip at least one thing, so the first thing can never be something that I'm considering after I've skipped something. That's the best way I can describe that. It's super confusing, but whatever. So either, back to this, so either I figure out, okay, what's the best I can do using, I've already used my skip, or the best I can do if I'm going to use the skip now. And then the value for these nodes here is just 1, if it's 1 plus the value of the previous node, right? So for any node here, I have to consider, the prev run, the max of, okay, so we're going to do some pointers here. So we'll have a variable called 1's, and it'll equal 0 here, 1 here, 2 here, 3 here, 0, 1, 2, 0, 1. So this is basically a running sum of the number of 1's that we've seen so far, right? So when we get here, the DP value is 3, right? Because it's just going to be 1 plus the previous thing, right? So this is a prefix sum notion of the number of 1's you've seen in a row. And then here we'll just call it run, I guess. Right, so the run here will be 0. Then the run here will be 1. And the run here will be 2, 3, 0. Because if you have 0, you can't do anything. Now when we get here, this is where it gets interesting, right? Because here the run is the best solution you have so far. So either I choose this 0 and add 1, or I choose the value here, which is 3, and I add 1 to get 4. And then the value here, it can only consider, well, it can say, okay, so when I'm looking at this node, I can consider the node, I can consider the state if I've already used the skip, which would give me 4, or I can consider the state where I use the skip now, which would give me 0. So obviously it's better to use 4 to get to 5. This is 0, of course. And then this is, well, I can either get 0 if I already used the skip for this node, or I can skip and get 2. So that would make this 3. And then at the end, you would just have to return the maximum thing that you got, which is 5. Okay. So there's a way to do this with linear space. Obviously, this is a linear time algorithm, right? Because we're just going to look at each node once and then do some computations. But if we get a little sophisticated and elaborate about how we do this, we can have this, we can make this space efficient and do it in constant space time. So the way that we're going to do that is, well, for any node, so for any run node, it's going to equal the maximum of run plus nums of I. Right? So if I is here, right? So if this is I, if I is at this node, so let's say I is here. Sorry, it's really ugly. That's why you don't stop making videos, because I didn't make any videos this weekend, so now I'm already rusty. That's how it goes. So if I is here, right? So I is pointing at this node. The best thing to do would be to pull from this previous run value, because at this point, run will equal 4. It'll be pointing here. So we could do runs plus nums of I, so we could use the run, or we could use a value here, which is 1's. And at this point, 1's will equal 0. So, or we could use 1's plus nums of I. Okay? And then after we're done with this iteration, runs would be here, and it would equal 5. So we've updated runs. And then we need to update 1's, right? So we need to move 1's over. So for the next iteration, and then figure out what 1's is. So now 1's would be 1 because we update it with an additional 1. And then what we need to do is check the solution that we got using runs to see if it's the max. So we'd update 1's as well. So then we'd say 1's equals nums of I times 1's plus 1. Right? Because if nums of I is 0, then 1's will be 0 because you lost your sum. Otherwise, you get an additional, right? You get an additional 1 because nums of I is 1. Okay? And you probably should multiply this thing by nums of I too. Because if nums of I is 0, you don't get any run, right? Every time you encounter a 0, it halts. Like, you don't get anything if the node you're looking at is a 0, because you're looking for the longest number of 1's. So the thing you're looking at is a 0. It's not going to provide you with that one subarray. So you just have to, you have to stop it there and say, there's nothing here that I can get, and continue. And then you just say, well, okay, well, my longest solution is then the max of whatever I think my longest solution was before and the current run that I've gotten. Okay, and you'll notice that none of this requires any additional arrays or any additional space. It's just 3 variables. Okay, so with that, let's go ahead and get into the problem. So we're going to have 1's equals nums of 0. So that's what it will start. Or no, actually, because when you do your first iteration, right? Because what we need to do is look at, the first thing we're going to look at is here. So 1's would be nothing because it doesn't even have anything to look at. Runs would be nothing. Okay. And longest would be nothing. So 1's would be nothing. Longest would be nothing because we don't know. And then run would also be nothing. Is that right? That seems so weird because I'm not even looking at the first value. Okay, no, longest would be the first value. So we just assume, since we're skipping the first value, let's just assume that nums of 0 is the longest solution. Or could you do that? Because what if nums of 0 is just 0? You have to skip one thing. If nums of 0 is 1 and you have to skip one thing. No, so 0. Okay. And then we'll look at I in range length of nums. And then we'll play this game. So we said run equals, we'll multiply whatever it is equal by nums of I, because if it's 0, we don't want to consider it, times the max of, well, if we just use the previous solution plus 1, right? Because if nums of I is 1, then this is 1. So we use the previous solution, which is we've run plus I would be this solution here, saying that I've already used the skip. Run was probably not the best name, but I've already called it that. So, or I use the skip now. So I use 1's plus 1. Then I update 1's, and I say 1's equals nums of I times the number of 1's plus an additional 1 if nums of I is a 1. And then I say my longest is the maximum of whatever I think my longest is and the current run that I have. And then at the end, I just return longest. I probably should have submitted that before. I mean, run it once before I submitted it. Yeah, because I'm an idiot. Okay. Good to know, good to know. So output is 2, should be 3. This is not considering this. Okay, so what am I doing wrong here? So we have 1's equals 0 for the first iteration. Sorry, so let's look at this. 1's equals 0, runs equals 0. Longest equals 0. So let's just write out this example because I'm not clearly seeing it just on the surface about what's wrong with my solution. 1, 1, 0, 1. Then we make the copy. We have all our skips. Okay, we have these nodes values here. And then obviously the solution is here to here. All right, so what's going on? What's wrong with my solution then? I don't understand. Okay, let me think about this for a second. Oh, dude. So run equals nums of I. Oh, okay. So remember, 1's is always trailing behind, right? Because, like, when you're looking at I here, right, runs is over here. Let's look at this solution here. Right, so for this solution here, notice that 1's is going to be always one behind the current iteration that you're looking at. So it's going to be counting nums from a previous iteration, right? So this should be nums of I minus 1, right? Like, when I update, when I look at this, right, first we start with 1's here. I is going to start here. And run's not going to consider this. Run will just be 0. Right? After this iteration is done, what's supposed to happen? Well, I equals 1. So then 1's would get updated with this value. So it would get updated with I minus 1. The minus 1 iteration, right? Because the I iteration is being updated. So we'd update the I minus 1 iteration. Okay. Try that. Oh, now it's 4. Why is it 4? Jesus help me. The first thing I'm going to do is I'm just going to make this one line. It's not going to make it work, but it's just like, you know, I don't know what's going on with me today, man. Run plus 1. So I don't change anything. Oh, this needs to start at 1. Oh my gosh, man. Or it's going to wrap around. Okay, so what did I miss here? This is such a hard problem for me for some reason, and I don't know why. But I know what I missed here, because longest could be the first number, right? Because I'm an idiot. So you don't have to skip the first number. So disregard what I said before. I don't even know if I'm going to post this video because this is so bad. You just have to skip one number, right? So you don't always have to skip the first number. You just can't have the first number be something you skip to, right? So the longest could technically be nums at 0, right? It just can't be a part of your run solution. Okay, so this was pretty pathetic. I apologize, guys. I don't know what's going on with me today, but that is the solution, I guess. Make this shorter, though, just to show you that I can really make it confusing if you're not already confused enough. There you go. All right, guys. Peace out.